Hello scholars! Today you're going to be learning about the quadratic formula. Quadratic formula is a very powerful formula that will allow you to solve any quadratic equation that you come across. Our objectives today will be that at the end of this lesson you are able to identify and write the quadratic formula, use the quadratic formula to solve quadratic equations, and explain the difference between rational, irrational, and complex solutions. If at any time you feel the need to pause this video or rewind, feel free to do so. So far, we have learned two different ways to solve a quadratic equation. We can solve it by graphing, which can help us find the x-intercepts, but it can be very tedious. And we can solve it by factoring. We can factor our equation and set all factors equal to 0, but not all quadratics will factor. There is, however, one more way. Ta-da! The quadratic formula. It can be used to solve any quadratic equation as long as that equation is in standard form. Remember, our standard form is y is equal to ax squared plus bx plus c. And the quadratic formula is expressed as x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So when you are solving a quadratic equation, there are three types of solutions that you can find. A rational solution, which consists of rational numbers, a number that can be represented as a part or a fraction or a whole number, such as 5 plus or minus the square root of 36, which can be rewritten as 5 plus or minus 6, which then gives us two solutions. One is 5 plus 6, which is equal to 11, and one is 5 minus 6, which is equal to negative 1. The second solution is one with irrational numbers in it. And an irrational number is a number that cannot be expressed as a fraction of a whole number, such as 3 plus or minus the square root of 5 over 6. The third solution is a complex solution that involves complex numbers. A complex number is a number that can be expressed in the form a plus or minus b times I, where a and b are real numbers. And what is I? Well, I is the imaginary number that fulfills the formula I squared is equal to negative 1, because there is not a real number that can be squared that equals negative 1. So what are our steps to solving with the quadratic formula? The first thing we need to do is make sure that our equation is standard form, and what that means is one side is going to be equal to 0. So we can set this as ax squared plus bx plus c is equal to 0. Then we identify and label our a, b, and c. So we're looking for what a is, what our b is, and what our c is. Then we plug in our a, b, and c into the quadratic formula, and we simplify to solve for all of our x. Alright, so let's try an example. Here we have 25x squared minus 40x plus 16 is equal to 0. And the first thing we need to do is make sure that our quadratic formula is in standard form. It looks like it is because one side is equal to 0, so we can rewrite that right here. Minus 40x plus 16 equals 0. Now we're going to label our a, b, and c. My a is 25, my b is negative 40, and my c is 16. Next, we're going to take our values and plug them into our quadratic formula, and we're going to have x is equal to negative 40, because we want our negative b, plus or minus the square root of negative 40 squared minus 4 times 25, which is our a, times 16, which is our c. We're going to do all of that over 2 times 25. And then we're going to simplify it, and our x is going to remain the same. Negative 40 is equal to 40 plus or minus the square root of 40 times negative 40 is 1600 minus 4 times 25, which is 100, times 16 is 1600. 2 times 25 is 50. Negative 16 minus 1600 is going to give us a 0, which is going to, the square root of 0 is going to be 0. It's going to drop out. And that's going to leave us with x is equal to 40 over 50 which is equal to 4 over 5, or 0.8, and that is going to be a rational solution. Okay, now we're going to try example number 2, which is negative 2t squared plus 9t plus 3 is equal to negative 6t squared. First thing that I notice is that my equation is not in standard form, so we're going to have to get it there. I'm going to add 6t squared to both sides, and that is going to give us 4t squared plus 9t plus 3 is equal to 0. And now that one on my side is equal to 0, I know that it is in standard form. I can label my a, b, and c. A is equal to 4, b is going to be equal to 9, and c is equal to 3. From there, I'm going to plug in my values into my quadratic formula. I'm going to replace x with t because I'm being asked to find t, not x. So t is going to be equal to negative 9 plus or minus the square root of 9 squared minus 4 times 4 times 3. And that is all going to be over 2 times 4. And finally, we're going to simplify and solve for our x. So t is going to be our x instead. So t is equal to negative 9 plus or minus the square root of 81 minus 16 times 3 is 48 over 8. And that's going to simplify to t is equal to negative 9 plus or minus the square root of 33 over 8. And that is an irrational answer. We cannot express that as part of a whole fraction. So our rational solution is negative 9 plus or minus the square root of 33 over 8. Okay, for example 3, we're going to solve the equation 2d squared plus 12 is equal to negative 8d. Once again, our equation is not in standard form, so we're going to have to help get it there. I'm going to add 8d to both sides. That is going to give me 2d squared plus 8d plus 12, and that is equal to 0, and that is going to be in standard form. My a is going to be 2, my b is going to be 8, and my c is going to be 12. Next, I'm going to plug those values into my quadratic formula. I'm going to replace my x with d because that's what we're asked to find, and d is going to be equal to negative 8 plus or minus the square root of 8 squared minus 4 times 2 times 12. That is all going to be over 2 times 2. And now we're going to simplify. D is going to be equal to negative 8 plus or minus the square root of 8 times 8, which is 64, minus 4 times 2 is 8, times 12 is 96 over 4. 64 minus 96 is going to give us a negative 32, so D is going to be equal to negative 8 plus or minus square root negative 32 over 4. Negative 32 can be rewritten as, the square root of negative 32 can be rewritten as D is equal to negative 8 plus or minus, and over 4, what we can write this as is the square root of negative 1 times the square root of, let's say, 16, and the square root of 2. The square root of negative 1 is I. The square root of 16 is 4. So we can have our D is equal to negative 8 plus or minus 4I times the square root of 2 over 4. We can also further simplify Our 8 and 4 and our 4 and 4 will reduce. So we'll have d is equal to -2 plus or minus I times the square root of 2. And that is a complex solution. Finally, I want to try an application problem with you. So we're going to assume an object is thrown off of a tower. The object falls with an initial velocity of 40 feet per second. The tower is 200 feet tall. The height of a falling object as a function of time can be modeled by the equation h of t is equal to -16t squared plus 40t plus 200. How long will it take for the object to reach the ground? One thing we need to keep in mind is we only want real solutions here. So we don't want something that's like -4 seconds, because that is 4 seconds before we throw the ball or the object. So what I'm thinking of is if I am standing on some place and I throw a ball off of that tower, that ball is going to travel up until gravity takes it and pull it down until it hits the ground. So what we're asking for is, where is this going to hit the ground? Or when, I'm sorry, when. So we're going to take our formula, which is -16t squared plus 40t plus 200. And we're going to solve for 0. Because we want to know when our height is 0. How long is it going to take for our height to reach 0? Now I could factor this, or I could use a graphing calculator or graphing, but we're going to solve using our new favorite quadratic formula. So our quadratic formula is going to be t is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. And our a is -16, our b is 40, and our c is 200. And now we're just going to plug it in, and t is going to be equal to -40 plus or minus the square root of 40 squared minus 4 times -16 times 200 all over 2 times -16. And that's going to simplify. T is equal to -40 plus or minus the square root of 1600 plus, because we're multiplying -4 times -16 times 200, it's going to give us positive 12,800 over -32. That's going to simplify to t is equal to -40 plus or minus the square root of 14,400 over -32. The square root of 14,400 is 120. So t is going to give us two answers. One is t is equal to -40 plus 1,200 over -32. Oops, 32, apologies. And or t is equal to -40 minus 120 over -32. This left one is going to simplify to -5 over 2. And this right one is going to simplify to 5. So we know that it happens at -5/2 seconds, or 5 seconds. We can't have a negative time jump because the ball can't be on the ground before we throw it. So this one is incorrect. Our correct answer is 5 seconds. Remember to complete your skill video and notes in Delta Math, and I look forward to seeing you in class.